Welcome to Algos and 10, Season 2, Episode 2 bonus. For tonight, we talk about the spooky, scary median and medians. Oh, tonight's also sponsored by Jackbox TV for the episode. And some Dove's candy. That's right. Due to social distancing, we can't do trick or treat properly, but I did get mentioned, get some trick or treating going. So yeah, without further ado, Algos and 10, Season 2. Episode 2 bonus, median and medians. You can see this episode is pretty dang scary because it is a Halloween episode, and I make it very scary with basically light and dark. Yeah. So let's scare you guys a little bit with some algorithms. First up, it's sponsored by Jackbox TV. You can play basically word spud, drawful, lie detector, fibbage, and of course my favorite, monster dating. The topics tonight, we have a quiz about recurrence relations, master theorem, median and medians and runtime analysis, and thank Wikipedia for all this stuff. So quick quiz. What is the general formula for recurrence relations? Ooh. Well, it's pretty obvious. It's T of n equals A times T n over B plus F of n, isn't it? Yeah, that's recurrence for you. So let's do a little quick review of the master theorem, shall we, boys and girls? So we have three cases of the master theorem. You got the first case, to split combine a problem into subproblems. You got a second case, to split combined comparable subproblems. And then split and combine dominated subproblem. And now I'm gonna annotate with my brain, orange colored, to annotate this beauty. So for the dwarf, you have a less than sign. For the equal, you have comparable sign. And of course, you have dominate is the greater sign, as they show right here very beautifully from Wikipedia. Yeah, that's great. And yet there are some examples of inadmissible. For example, this is one of the inadmissible versions. I'll put the lamp down to type this thing. So it's one example that's inadmissible. F of n. 1 over 13. 1 over 13. 1 over 13. O of n plus n squared. That is inadmissible, but you cannot actually do fractional constants. Another inadmissible version, f of n equals 1 over infinity of n, because that's basically going to be 0, which is not even a real value. So it's going to be 0. And the third most obvious inadmissible version is f of n equals 1, which is just a bloody straight line. Right there. So that is basically the beginning of the horror story of median and medians. Moving on. A little quiz for you guys. I'll give you guys a few minutes to think about the quiz. T of n equals O n squared. Which cases belong to? Third is recurrence. Kind of solve the recurrence is very important. T of 1 equals 0. T of n equals T of n over 5 plus O of n. And then the CLRS example. That's right. CLRS is a very interesting indeed situation here. Yeah, CLRS. So for CLRS is basically an MIT book that I think a lot of people are well aware of. It is, of course, going to be none other than good old Corman, Levinstein, Corman, Charles. So we visit Corman, Learson, Revest, and Clifford Stein. This is like the algorithm's granddaddy Bible of Algos and 10, and obviously my LeetCode buddy. So getting back to the recurrence quiz for this Algos and 10, I'll give you guys a couple minutes to think about. I'll tell you guys a spooky, scary story that's called the median of medians. Imagine if you have a candy bar here, and then we eat it because we want to be happy before doing LeetCode or applying for jobs in this economy. Oh. For me, it's fun. Like eating candy bar from a baby. It's so cruel, yet so delicious. That's enough of time, I think. That's math, answer questions. So case 1, we have O of n to C, because C is basically 2 in this case. Case 2, you have B equals theta of n, because you're writing the case 2 of the massive theory. And case C is theta of n. And a little log math trick we have is if you have a log base B of A, you do log base C of B over log base C of A. C is usually a common base in decimal or 10, binary or 2, octal or 8. And it becomes log base C of B over A. An example from the problem we had before, log base 14 of 13 is log base 10 of 13 over log base 10 of 14, which is log base 10 to 13 of 14, which is 0.972. And that is one of the best looking OPSs for the Atlanta Braves in the World Series. Now, applying candy bars to median and medians. Let's say we have a nice candy bar for trick-or-treating. And we've done this before in season 1, episode 7 in the chocolate factory. But this is a more advanced recursive treatment of the problem, because back then, we just slapped on a runtime. Now this time we use recurrence relations to derive it straight up. Yeah, so part 2 is basically we divide the bar into partitions of n rows. We see from the original algorithm to divide into 5 portions, which is not shown here, but you can divide into 5 different portions. In a division of n over 5. And now this gets a little bit scary like this for Halloween. And we continue breaking the bars in half, resulting in n over 5 times half or n over 10 groups. This will be done recursively until no more bars can be split. Then we finally have the median elements of 70 to 30, and I'll show you a little annotation for that. Yeah. So for example, this entire piece is like 70%, and I'm going to change it to black for the other one. This entire piece is going to be the 30%. So you want to be very careful with which piece you're selecting here for the algorithm. So basically the pivot over here, this line, the pivot line, is the ceiling of 3 over 10n elements greater than the pivot, and a 7 over 10 elements less than the pivot. So we finally get the recurrence of, drum roll, T of n equals the number of pivot partitions plus medians of pivots plus work done per split, n over 5 plus 7 over 10 plus c times n, where c is greater than 1. And then we now do some induction to do the runtime analysis. We can apply induction. T of 0 case is just c of n. T of 1 case, c of n. T of whatever case, c of n. The T of n case is n over 5 plus 7 over 10n plus c of n, which is 2 of 10, 2n over 10 plus 7n over 10. That's a little typo. I'm so sorry. I should probably be careful there. And then plus c times n, which is 9 over 10n plus c times n, which is 9 over 10 plus c. And ooh, that's scary, isn't it? It's basically c of n or O of n is linear. We remove the constants when applying induction. So see you guys in 2 weeks for the, of course, airplane episode and air priori. Episode 9 will be on Veterans Day, 11/11/2021. Make sure to like and subscribe. Happy Halloween. And this is Jason Liu, Algos in 10. See ya later. Good night.